Hello dear students, welcome back to the online classes. Today I am going to discuss about the new concept in this topic, that is earth magnetism. Earth itself acts as a magnet. ಯಾವ ರೀತಿ ಇದು ಅರ್ತ್ ತನ್ನಿಂತಾನೆ ಮ್ಯಾಗ್ನೆಟ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ, ಆ ಕಾನ್ಸೆಪ್ಟ್ ಬಗ್ಗೆ ನಾವು ಇವತ್ತು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. earth magnetism, it is a separate branch of physics. It is the separate branch of physics which deals with the study of magnetism of earth. Which deals with the study of magnetism of earth. It is also called geomagnetism. Geo means earth. The earth magnetism, it is also called geomagnetism, or it is also called terrestrial magnetism. Earth magnetism, it is the branch of physics which deals with the study of magnetism of the earth. ಭೂಮಿಯ ಗುರುತ್ವ ಎಂಬತಕ್ಕಂತಹ ಅಂಶದ ಬಗ್ಗೆ ಅಧ್ಯಯನ ಮಾಡೋದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ಆಕರ್ಷಣೆ ಅಂತ ಕರಿತೀವಿ. ಆಕರ್ಷಣೆಯ ಬಲದ ಬಗ್ಗೆ ಅಧ್ಯಯನ ಮಾಡ್ತಕ್ಕಂಥ ಕಾನ್ಸೆಪ್ಟಿಗೆ ಜಿಯೋ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಂತ ಕರಿತೀವಿ. ಭೂಮಿಯ ಅಯಸ್ಕಾಂತದ ಗುಣಗಳ ಬಗ್ಗೆ ಅಧ್ಯಯನ ಮಾಡ್ತಕ್ಕಂಥ ಬ್ರಾಂಚಿಗೆ ಜಿಯೋ ಮ್ಯಾಗ್ನೆಟಿಸಮ್. ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ terrestrial magnetism. And there are three important elements in this concept: magnetic declination, magnetic inclination, and horizontal component of the earth magnetic field. Now we will see one by one. The earth magnetism, the word itself says it is the branch of physics which deals with the study of magnetism of the earth. Earth magnetism, magnetism of the earth, study of magnetism of the earth. It is also called geomagnetism or terrestrial magnetism. It means the strength of the earth's magnetic field, it varies from one place to another place, or one place on the earth's surface. Its value is in the order of 10 to the power of -5 Tesla. Earth is considered to be as a huge magnet having a magnetic field of strength of the order of 10 to the power of -5 Tesla. And originally the magnetic field was thought of as arising from a giant bar magnet, and it is placed approximately along the axis of rotation of the earth and deep in the interior. The magnetic field of the earth, it changes from place to place with the time at a given place on this earth, and the magnetic field of the earth is believed to arise due to the electric currents passed or produced by a convective motion of metallic fluids. And this simple picture is certainly not correct, and the magnetic field is now, it thought that arise due to the electrical currents, arise due to the electrical currents, and this field is arise due to the electrical currents, and this electric current is produced by convective motion of metallic fluids in the outer core of the earth. This is known as the dynamo effect. This is known as the dynamo effect. Suppose if I consider this is the surface of the earth. The magnetic field is now that the arise due to the electrical current produced by the convective motion of metallic fluid in the outer core of the earth. ಇಲ್ಲಿ outer core of the earth, ಸುತ್ತಮುತ್ತಲ ಏನು ಸಮುದ್ರ ಇದೆ ನಮಗ, ಆ ಸಮುದ್ರದಲ್ಲಿ ಔಟರ್ ಕೋರ್ ಆಫ್ ದ ಅರ್ತ್ ಅಲ್ಲಿ ಮಾಲ್ಟನ್ ಐರನ್ ಅಂಡ್ ನಿಕೆಲ್ ಎಂಬತಕ್ಕಂತಹ ಮೆಟಲ್ ಇದೆ. ಹೌದಾ? ಕನ್ಸಿಸ್ಟಿಂಗ್ mostly of molten iron and nickel in the outer core of the earth, and due to this the friction, the charge is produced. Due to the friction, charge is produced. In this concept, the magnetic field of the earth is believed to arise due to electric currents produced by the convective motion of the metallic fluids. This process is called dynamo effect, and the magnetic field lines of earth resemble that of a hypothetical magnetic dipole located at the center of the earth. It is called dynamo effect. ಭೂಮಿ ಕೂಡ ಒಂದು ಗುರುತ್ವಾಕರ್ಷಣೆ ಶಕ್ತಿ ಇದೆ. Earth itself acts as a magnet. ಅಂದರೆ ಭೂಮಿಗೆ ಎಲ್ಲಿಂದ ಗುರುತ್ವಾಕರ್ಷಣ ಶಕ್ತಿ ಬಂತು? ಒಂದು ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟನ್ನು ಥ್ರೋ ಮಾಡಿದಾಗ ಅದು ವಾಪಸ್ ಕೆಳಗೆ ಬರುತ್ತೆ. ಅಂದರೆ ಎಲ್ಲಿಂದ ಬಂತು ಭೂಮಿಗೆ ಗುರುತ್ವಾಕರ್ಷಣೆ ಶಕ್ತಿ? ಗುರುತ್ವ ಅಂತ ನಾವು ಕರಿತೀವಿ, ಆಕ್ಸಿಲರೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ. ಅದನ್ನು ಪ್ರೊಸೆಸ್ ಇಲ್ಲಿ ಏನಂತ ಕರಿತೀವಿ? ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಮೀನ್ಸ್ ಇಟ್ ಇಸ್ ದ ಪ್ರೊಸೆಸ್ ಇನ್ ವಿಚ್ iron, cobalt, nickel are attracted towards the surface, or it is the phenomenon of attracting. Right? The magnetic field is now thought to arise due to electrical currents produced by convective motion of metallic fluids. This is called dynamo effect, and this is the interior core of the earth. Interior core of the earth. Why does the earth have a magnetic field? It is a very interesting phenomenon. Why does the earth have a magnetic field? ಭೂಮಿಗೆ ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಯಸ್ಕಾಂತೀಯ ಗುಣ ಯಾಕೆ ಬಂತು? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಟ್ ಮೀನ್ಸ್ ಅಯಸ್ಕಾಂತೀಯ ಗುಣ. Why does the earth have a magnetic field? The earth has at its center a dense liquid core of about half the radius of earth with a solid inner core. It has center a dense liquid core. Center a dense liquid core. Now we consider this is a dense liquid core of about half the radius of the earth. It has at its center a dense liquid core. ಇದರಲ್ಲಿ ಏನಿದೆ ನಮಗೆ dense liquid core ಇರತಕ್ಕಂಥ ಕಾನ್ಸೆಪ್ಟ್ of about half the radius of the earth. ಹಾಫ್ ಆಫ್ ದ ರೇಡಿಯಸ್ ಆಫ್ ದ ಅರ್ತ್ ಅನ್ನು ನಾವು ಕ್ರಾಸ್ ಮಾಡಿ ಹೋದಾಗ ಅಲ್ಲಿ ಒಂದು ಸರ್ಟಿನ್ ಲಿಕ್ವಿಡ್ ಇದೆ. ದಟ್ ಈಸ್ ಸಾಲಿಡ್ ಇನ್ನರ್ ಕೋರ್. ದ ಸಾಲಿಡ್ ಇನ್ನರ್ ಕೋರ್, ದಿಸ್ ಕೋರ್ ಈಸ್ ಮೋಸ್ಟ್ಲಿ ಮೇಡ್ ಆಫ್ molten iron and nickel, perhaps mixed with some lighter elements. The most abundant materials are molten iron and nickel, perhaps mixed with some lighter elements. Circulating ions of iron and nickel in highly conducting liquid region of earth core might be forming current loops. The charge is produced friction. Here the molten iron and nickel, due to that highly conducting liquid region of earth core, it might be performing current loops and producing the earth magnetism. ಅವುಗಳ ಮಧ್ಯೆ ಉಂಟಾಗ್ತಕ್ಕಂತಹ ಘರ್ಷಣೆಯಿಂದ ಚಾರ್ಜ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ. When the charged particles are passes through the surface of the earth, then the magnetic field is produced. This is very simple concept. The circulating ions of iron and nickel in highly conducting liquid region of earth's core might be forming current loops and producing earth magnetism. And what is earth magnetism? Earth, it has a two pole geographically. One is north pole and another one is south pole. Itself has a huge magnetic field. It is in the order of 10 to the power of minus 5 Tesla. And it had a huge bar magnet embedded at its center. The magnetic field lines, already I discussed in the previous video, magnetic field lines are always starts their journey from north pole and ends their journey to the south pole. It starts from north pole and reach the south pole externally and south pole to north pole internally. North pole to south pole externally, south pole to north pole internally. Earth itself has a huge magnetic field. It acts as a bar magnet. It acts as a bar magnet. And the magnetic field lines are emerge from near the geographic north pole and re-enter it at the south pole. ಭೂಮಿಯಿಂದ ಹೊರಗಡೆ ಬರಬೇಕಾದ್ರೆ ಯಾವ ದಿಕ್ಕಿನ ಕಡೆಯಿಂದ ಬರ್ತಾವು? ನಾರ್ತ್ ಪೋಲಿಂದ ಹೊರಗಡೆ ನಮಗೆ ಏನಾಗ್ತಾವು? ಎಮರ್ಜ್ ಆಗ್ತಾವೆ. ನಾರ್ತ್ ಪೋಲಿಂದ ಹೊರಗಡೆ ಬರಬೇಕಾದ್ರೆ ಏನಾಗ್ತಾವೆ? ನಮಗೆ ಎಮರ್ಜ್ ಆಗ್ತಾವೆ. ಸೌತ್ ಪೋಲಲ್ಲಿ ಏನಾಗ್ತಾವೆ? ನಮಗೆ ರೀ-ಎಂಟರ್ ಆಗ್ತವೆ. ಸೌತ್ ಪೋಲಲ್ಲಿ ಏನಾಗ್ತಾವೆ? ರೀ-ಎಂಟರ್. ದಿಸ್ ಇಸ್ ದ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. Magnetic field lines or the earth magnetic field lines emerge from near the geographical north pole and re-enter it at the south pole. Re-enter it at the south pole. And the nature of the field around the earth. The nature of the field around the earth, it varies in both strength and direction. It varies in both strength and direction. The magnetic field, it varies from different in different places. The strength of the magnetic field, it varies from different in different places and it shows different direction in different places. And the earth magnetic field is strongest at the magnetic poles. Earth magnetic field is strongest at the magnetic poles. Suppose if you consider this is a bar magnet, it has a two pole, one is north pole and another one is south pole, and the iron fillings are sprinkled over the surface of the bar magnet. Here the n number of concentric circles are produced. At these 2 points, a north pole and south pole, at these 2 points the magnetic field is very strong. Here also the earth's magnetic field is strongest at the magnetic poles. This is the north pole and this is the south pole. At these two regions the magnetic field or earth magnetic field is very strong and weakest near the equator. Weakest near the equator. This is the equatorial line. ಸಮಭಾಜಕ ವೃತ್ತ ಅಂತ ನಾವು ಕರಿತೀವಿ ಕನ್ನಡದಲ್ಲಿ. Equatorial line. At the equatorial line it is a very weakest. The magnetic field is strongest at the magnetic poles and weakest near the equator. And the pole near the geographic north pole of the earth is called north magnetic pole. The pole near the geographic north pole of the earth. ಯಾವುದೇ ಒಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಕಂಪಾಸ್ ನೀರಲ್ಲಿ ನಾವು ಇಟ್ಟಾಗ ಆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಕಂಪಾಸ್ ನೀರಲ್ಲದ ಒಂದು ಪೋಲು ನಿಯರ್ ದ ಜಿಯೋಗ್ರಫಿಕ್ ನಾರ್ತ್ ಪೋಲ್ ಆಫ್ ದ ಅರ್ತ್ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ, ನಾರ್ತ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪೋಲ್ ಅಂತ ಕರಿತೀವಿ. ಆ್ಯಂಡ್ ಸಿಮಿಲರ್ಲಿ ದ ಪೋಲ್ ನಿಯರ್ ದ ಜಿಯೋಗ್ರಫಿಕ್ ಸೌತ್ ಪೋಲ್ ಈಸ್ ಕಾಲ್ಡ್ ಅ ಸೌತ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ pole. It is very simple concept, right? And the next thing is there is some confusion in the nomenclature of the poles. If one looks at the magnetic field lines of the earth, now magnetic field lines of the earth anna nodidaga there is some conclusion the nomenclature of the poles. Yenide illi conclusion adannu nodona. One sees that unlike in the case of a bar magnet, in case of bar magnet magnetic field lines go into the earth at the north magnetic pole and comes out from the south magnetic poles. South magnetic poles. But the convention arose because the magnetic north was direction to which the north pole of the magnet needle is pointed. This is also the based on the properties of the magnetic field. When I explained the properties of magnetic field lines and the introduction concept of magnet, some students are asking me the questions. So how this magnetic field is varies when the lodestone is suspended freely, it always lies geographically from south to north direction. It is suspended in north to south, but it always direction is from south to north direction. How? Because the north and the north pole of the magnet cannot attract each other. Then south and south pole of the magnet cannot attract each other. North pole of the magnet is attracted towards the south pole and south pole of the magnet is attracted towards the north pole. That's why the little bit confusion is there. The convention arose because the magnetic north was the direction to which the north pole of the magnetic needle is pointed. The north pole of the magnetic needle is pointed and the north pole of the magnet was so named as it was the north seeking pole. And in reality the north magnetic poles behaves as a south pole of the bar magnet. It is very interesting concept. ನಾವು ಭೂಮಿಯಲ್ಲಿ ನಾರ್ತ್ ಮತ್ತು ಸೌತ್ ಅಂತ ನಾವು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೀವಿ, ಬಟ್ ರಿಯಾಲಿಟಿ ಹೋದಾಗ ನಾರ್ತ್ ಕಡೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ನಮ್ದು ಹತ್ರ ಒಂದು ದಿಕ್ಸೂಚಿ ಇತ್ತು ನಿಮ್ಮ ಕೈಯಲ್ಲಿ ಅಂತಂದ್ರೆ ಅವಾಗ ಆ ಸೌತ್ ಇರ್ತಕ್ಕಂಥ ಡೈರೆಕ್ಷನ್ ನಾರ್ತ್ ಕಡೆ ತೋರಿಸುತ್ತಾ, ನಾರ್ತ್ ಇರ್ತಕ್ಕಂಥ ಡೈರೆಕ್ಷನ್ ಸೌತ್ ಕಡೆ ತೋರಿಸುತ್ತೆ. ಬಿಕಾಸ್ ಆಫ್ the property like poles are repel each other, unlike poles are attract each other. Due to that concept, the reality the north magnetic pole behaves like the south pole of a bar magnet inside the earth and vice versa. It is in opposite. Okay. And the next interesting concept is there are three important magnetic elements. There are three important magnetic elements. What is earth magnetism? It is the branch of physics which deals with the study of magnetism of the earth. It having a magnetic field in the order of 10 to the power of -5 Tesla and it varies from one place of the earth to another place of the earth, and magnetic field of the earth is believed due to arise due to the electric currents produced by the convective motion of that fluids or metallic fluids in the outer core of the earth, that is called a dynamo effect. That is called a dynamo effect. The next concept of this topic is that is magnetic elements. There are three important magnetic elements are there: magnetic inclination, magnetic declination, and horizontal component of the earth magnetic field. To describe this magnetic field of the earth at any place on the surface of the earth, three quantities or elements are required. Three quantities or elements are required. The first element is that is magnetic declination, mathematically denoted by the symbol theta, and the second element is magnetic inclination, mathematically denoted by the symbol delta, and the third element is horizontal component of the earth magnetic field. The first element is magnetic declination, second element is magnetic inclination, and third element is horizontal component of the earth magnetic field. These are the three very important magnetic elements. To describe the magnetic field of the earth at any place, three quantities or elements are required. Remember these 3 points. It is a 1 mark fixed question. Define magnetic declination or magnetic inclination or horizontal component of the earth magnetic field. The 1 mark question is fixed for your annual exam on this concept. Okay. Now we will see the definition of the magnetic declination. Magnetic declination anta ನಾವು ಯಾವುದಕ್ಕೆ ಕರೀತೀವಿ? It is the angle between the magnetic meridian and geographic meridian. Angle between the magnetic meridian and geographic meridian. Magnetic meridian, geographic axis and magnetic axis. These are the 4 parameters. These are the 4 parameters. Suppose if you consider this is the earth's surface, it has 2 poles. One is the north pole and this another one is south pole. One is north pole and another one is south pole. A straight line passing through the geographic north pole to a straight line passing through the geographic north pole to geographic south pole. This is called geographic axis. This is called geographic axis. A straight line passes through the geographic north pole to geographic south pole. A straight line passing through the geographic north pole to geographic south pole is called geographic axis. Geographic axis of this earth. And magnetic axis means any magnet is placed on the surface of this earth. It has a 2 pole, one is north pole and another one is south pole. A straight line passes through the magnetic north pole to magnetic south pole. A straight line passes through the magnetic north pole to magnetic south pole is called magnetic axis. A straight line passes through geographic north pole to geographic south pole is called a geographic axis. A straight line passes through magnetic north pole to magnetic south pole is called magnetic axis. It is called a magnetic axis. And geographic meridian means a vertical line passes through the geographic axis of the earth. ಇಲ್ಲಿ ನೋಡಿ, ಒಂದು ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಸೌತ್ ಪೋಲಿಗೆ ಅರ್ತ್ ಅಲ್ಲಿ ನಾವು ಲೈನ್ ಅನ್ನು ಎಳೆದೀವಿ ಅಂದ್ರೆ ಇದಕ್ಕೆ ನಾವೇನಂತ ಕರಿತೀವಿ? ಜಿಯೋಗ್ರಾಫಿಕ್ ಆಕ್ಸಿಸ್. It is called a geographic axis. A vertical line passes through the geographic axis of the earth. This is called geographic meridian. It is called a geographic meridian. And magnetic north pole to magnetic south pole. Magnet and place ಮಾಡ್ತೀವಿ ನಾವು. Here this is the north pole and south pole. A straight line passes through magnetic north pole to magnetic south pole. A straight line passes through. A straight line passes through. See here, magnetic axis. A straight line passing through the magnetic north pole to magnetic south pole. It is called magnetic axis. And a vertical plane passing through the magnetic axis of the earth. A vertical plane passes through the magnetic axis of the earth. A vertical plane passes through the magnetic axis of the earth. This is called a magnetic equator or magnetic meridian. There are four important definitions: geographic axis, magnetic axis. Geographic axis means a straight line passes through geographic north pole to geographic south pole, and a straight line passes through magnetic north pole to magnetic south pole is called magnetic axis. Geographic meridian means a vertical plane passes through the geographic axis of the earth is called geographic meridian, and a vertical plane passes through the magnetic axis of the earth is called a magnetic meridian. Now, from using these simple definitions, now I am going to define the magnetic elements of earth. The first one is magnetic declination. ನಿಮಗೆ ಕೊಟ್ಟಿರತಕ್ಕಂತ ನೋಟ್ಸ್ ಅಲ್ಲಿ ನೋಟ್ ಅಂತ ನಾನು ಕೊಟ್ಟಿದ್ದೇನೆ. Geographic axis, magnetic axis, geographic meridian and magnetic meridian. First definition is magnetic declination. It is the angle between the magnetic meridian and the geographic meridian. Angle between the magnetic meridian and geographic meridian. It has a two pole, one is north and another one is south. Suppose the magnetic needle is placed on this surface. Placed on this surface here. This angle is called, this is the magnetic declination, geographic meridian and the magnetic meridian, or geographic axis to the magnetic axis, both are same. Magnetic declination, it is the angle between the magnetic meridian and geographic meridian, or magnetic axis to the geographic axis. This is called magnetic declination. A freely suspended magnetic needle does not show true geographic north and true geographic south direction, because two poles are, like poles are repel each other, unlike poles are attract each other. Freely suspended magnetic needle does not show the true geographic north and true geographic south direction, and the angle between the magnetic axis and geographic axis of the earth at the place is called magnetic declination, or angle between the magnetic meridian and geographic meridian of the earth at a place, it is called magnetic declination. And declination is greater at the higher altitude and smaller at the equator. Magnetic declination means it is the angle between the magnetic meridian and the geographic meridian, that is called magnetic declination. And this is the diagram of the magnetic declination. The angle between the magnetic meridian and geographic meridian is called magnetic declination, or angle between the magnetic axis to the geographic axis is called magnetic declination. It is mathematically denoted by the symbol theta. It is higher value in the altitude and very lower value in the equator. And the next concept is magnetic declination. Magnetic declination. Magnetic declination. Here, the theta, it is the angle of declination, the angle between the geographic meridian to the magnetic meridian. Angle between the geographic meridian to the magnetic meridian. Here this dotted line indicates the geographic meridian and this line indicates the magnetic meridian. This is geographic meridian and this is magnetic meridian. Angle between the geographic meridian and magnetic meridian, this angle theta, this is the angle of declination. The angle between the geographic meridian to the magnetic meridian is called magnetic declination. It is mathematically denoted by the symbol theta. It is an imaginary concept. And small angle between magnetic axis and geographic axis at a place is defined as the magnetic declination. It is an first important parameter. And this is the true north pole and this is the magnetic north pole. True north pole and magnetic north pole, this is the compass needle. True north pole and magnetic north pole are repel away from each other due to the property of magnetic field. The two like poles are repel each other, unlike poles are attract each other. That's why the magnetic north pole and the true north pole are repel each other. True north pole and magnetic north pole are repel each other. This is the angle of declination. Angle of declination. Some 1 mark questions on this concept. the small angle between magnetic axis and geographic axis at a place. Angle between the magnetic axis and geographic axis at the place, it is called magnetic inclination, magnetic declination, magnetic dip, and none of the above. Magnetic declination is the right answer because the angle between the magnetic axis to the geographic axis, or angle between the magnetic meridian to the geographic meridian, is called magnetic declination. And the magnetic field is now thought to arise due to electrical current. Earth itself acts as a huge magnet. How the magnetic field is produced by the earth? It is thought that it arises due to electrical currents produced by convective motion of the metallic fluids, so that consistently molten iron and nickel are the most abundant elements occur in the outer core of the earth, and this process is called dynamo effect. This is called dynamo effect. Dynamo effect. And the next concept is magnetic inclination. Magnetic inclination, it is also called magnetic dip. Magnetic inclination, or it is also called magnetic dip, and it is mathematically denoted by the symbol I or delta. I or delta. It is the angle between the direction of the total earth magnetic field. Direction of the total earth magnetic field and the horizontal line in the magnetic meridian. It is the angle between the direction of the total earth magnetic field and the horizontal line in the magnetic meridian. It is called magnetic dip or inclination. The angle between the direction of total intensity of the earth's field with the horizontal line in magnetic meridian. With the horizontal line in magnetic meridian, the angle between the direction of total intensity of the earth's field with the horizontal line in the magnetic meridian, it is called magnetic dip. It is mathematically denoted by the symbol delta. At the poles, the angle of dip is 90 degree. At the equator, the angle of dip is 0 degree. At the poles, the angle of dip, or it is also called inclination. At the poles, the angle of dip is 90 degree, and at the equator, the angle of dip is 0 degree. It is a very important. Remember this point. What is the value of the angle of dip in the equator? That is 90 degree. The value of angle of dip at the equator is 0 degree. Remember this point. This is the 1 mark question. And here, this is the horizontal component of the earth magnetic field. And the angle between the magnetic meridian, this is the magnetic meridian, a vertical plane passing through the magnetic axis of the earth is called magnetic meridian. This is magnetic meridian, right? Angle between the direction of total intensity of the earth's field, this is the direction of total intensity of the earth magnetic field, that is mathematically denoted by the symbol HE. HE means earth's field, intensity of earth's field with the horizontal line in magnetic meridian, and it is represented by the symbol delta. At the poles, the dip value is 90 degree. At the equator, the angle of dip value is 0 degree, and this is the angle between the direction of total intensity of earth field with the horizontal line in magnetic meridian. And the next concept is the dip at a place can be determined by an apparatus that is known as dip circle, and the needle rotates freely in a vertical plane of that scale. It pointed ends move over the graduations on the scale, which are marked as 0 degree to 0 degree in the horizontal and 90 to 90 degree in the vertical directions. In the vertical direction, this is the magnetic compass needle to measure that value. From using this apparatus, the dip circle or the magnetic dip inclination and magnetic declination are measured by using this magnetic compass needle, right? And the declination is greater at higher latitudes and smaller near the equator. The declination value is, it is greater at the higher latitudes and smaller at near the equator, and the declination in India is very small. Declination in India is very small, and it being 0 degree 41 minutes in east at Delhi and 0 degree 58 minutes 0 degree 58 minutes at Mumbai. So at both these places the magnetic needle, it shows the true north quite accurately, not exactly, quite accurately, because the two unlike poles are repel each other. It does not show the accurate measurement. Here the both the places, in these both places the magnetic needle shows the true north quite accurately. And there is a one more quantity of interesting. If a magnetic needle is perfectly balanced about a horizontal axis, perfectly balanced at about a horizontal axis, so that it can swing in a plane of the magnetic meridian. It is a very interesting phenomenon. If a magnetic needle is perfectly balanced about a horizontal axis, it can swing in that plane of the magnetic meridian. Remember this point also. And the needle would make an angle with the horizontal. This is also known as the angle of dip, or this is known as inclination. And dip is the angle that the total magnetic field of the earth makes with the surface of the earth. And it is varies from one point to another point. The magnetic meridian plane at point P on the surface of the earth, the plane section is through that the earth, and it is resolved along the two components. One is horizontal and another one is vertical. Along the horizontal, it is mathematically denoted by the symbol BH, and along the vertical, it is mathematically denoted by the symbol BV. The angle that B makes with BH is the angle of dip. Here, this is the earth magnetic field. The magnetic field at point P resolves into two components. The earth magnetic field at point P can be resolved into two components. One is horizontal component and another one is vertical component. And angle that B makes with this BH, the angle B makes, this is the magnetic field, it is resolved into two components. The angle that B makes with BH is the angle of dip. This is called angle of dip. And true north, here this diagram shows the true north and true south pole. In most of the northern hemisphere, the north pole of the dip needle tilts downwards. Likewise, in most of the southern hemisphere, the south pole of the dip needle tilts downwards. And to describe this magnetic field of the earth at a point on its surface, we need to specify the three quantities like the declination and the angle of dip or inclination and the horizontal component of the earth magnetic field. These are the three important magnetic elements of the earth. Now we will see the horizontal component. These are known as the elements of the earth magnetic field, and representing the vertical component by ZE, we have ZE is equal to BE sin I. ZE is equal to BE sin I, and HE is equal to BE cos I. This is the horizontal component. ZE representing the vertical component. Sorry, this is vertical component. ZE, this is vertical component. HE, this is horizontal component. For this vertical component, the earth magnetic field B into sin I. For this horizontal component, earth magnetic field B into cos I. It gives the sin by cos is equal to tan. Tan I is equal to ZE divided by HE. This is a very important formula to calculate the values. Tan I is equal to ZE divided by HE. ZE means it is the vertical component of the magnetic elements of the earth. HE means horizontal component of the magnetic field of the earth. Tan I is equal to ZE divided by HE. And magnetic inclination or magnetic dip. This is the magnetic inclination. It shows the magnetic inclination or magnetic dip. It is the angle between the horizontal component of the earth magnetic field to the magnetic axis or magnetic equator of the earth. The angle between the horizontal plane of the earth or horizontal component of the earth magnetic field to the magnetic axis of the earth. This is called magnetic inclination or magnetic dip. And the angle which the direction of total strength of earth's magnetic field makes with the horizontal line in magnetic meridian. The angle which the direction of total strength of earth's magnetic field makes with the horizontal line in magnetic meridian. The angle between, the very simple definition, it is the angle between horizontal plane of the earth magnetic field to the magnetic axis of the earth. It is called magnetic inclination or magnetic dip. The angle of horizontal component of the earth magnetic field between the horizontal plane of the horizontal axis and the axis of freely suspended magnetic needle is called angle of dip or inclination. And what happens to our compass needle at the poles? Why the compass needle is repel away at the poles? What happens to our compass needle at the poles? Here, this is the compass needle, free floating needle that lines up with the magnetic north. Here, this is the geographic north pole and this is geographic south pole. When the magnetic compass needle is placed on the surface of the earth, free floating needle that lines up with the magnetic north, and it does not show true geographic north pole and true geographic south pole. Okay. Compass needle consists of a magnetic needle which floats on a pivotal point. And another concept is, from using that value magnetic declination at a place, it allows us to correct the compass to determine the direction of the true north. And when this compass needle is held at this level, and the compass needle is held at this level, see here, this diagram, it points along the direction of the horizontal component of the earth's magnetic field at this location. And the freely compass needle that lies up with the magnetic north pole and it is held at a level, it points along the direction of the horizontal component of earth magnetic field at this location. Therefore, the compass needle would stay along the magnetic meridian of the place. It stay along the magnetic meridian of the place, so that in some places on the north there are deposits of magnetic material which cause the compass needle to deviate from the magnetic meridian. In some places on the earth there are deposits of magnetic materials which cause the compass needle to deviate from magnetic meridian. So, what happens if we take our compass to the magnetic pole? At the poles, magnetic field lines are converging or diverging vertically so that horizontal component is negligible. And if the needle is only capable of moving in a horizontal plane, it can point along any direction, rendering it useless a direction finder. What happens if we take our compass needle to the magnetic pole? Magnetic pole anna ಒಂದು ದಿಕ್ಸೂಚಿಯನ್ನು ತಗೊಂಡು ಹೋಗಿ ಅಲ್ಲಿ ಇಟ್ಟಿವೆ ಅಂತಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪೋಲ್ ಹತ್ರ, at the poles magnetic field lines are converging or diverging vertically so that horizontal component is negligible. If the needle is only capable of moving in a horizontal plane, it can point along any direction, rendering it useless as a direction finder. Then one needs such a case is a dip needle which is a compass pivoted to move in a vertical plane or containing the magnetic field of the earth. And the needle of the compass then shows the angle which the magnetic field makes with the vertical. And at the magnetic force, the needle will point straight down. These are all the properties of that magnetic compass needle. Already what I have provided to your notes. Refer that notes. Okay.